The next group of compounds we'll discuss are the compounds called acids. Acids are an unusual group of compounds in that acids are covalent compounds you recall this means that there are no metals in the compound. However, they behave like ionic compounds when they're added to water, which means that they split up in water into a positive ion, which is always hydrogen plus 1, and some sort of a negative ion. The negative ion could be a nonmetal. The negative ion could be a polyatomic ion. So when we look at formulas for acids, hydrogen is always the first element. That's how you will recognize acids out of a group of compounds. I should say element singular. Now we have two groups of acids. Depending on what is the hydrogen bonded to. The first group is called the polyatomic or oxy acids. They're named because its hydrogen is attached to a polyatomic ion. It's bonded to one of the polyatomic ions. The second group are called the binary acids. Binary means 2. And these are called binary acids because there's just hydrogen plus one other nonmetal. So there's only 2 elements in a binary acid. There's going to be at least 3 elements in a polyatomic or oxy acid. The name oxy acid comes from the fact that a lot of the polyatomic ions, if you look at their formulas, contain several oxygens. So that's where you get the nickname oxy acids for this group. Now, because these groups are different in the way their composition, they also have slightly different rules as far as how they are named. So we're going to take a look at the rules for these two groups of compounds. Let us start with the polyatomic acids. Now, to name a polyatomic acid, you're going to look at the name of the polyatomic ion, okay, and you're going to change the end to something different. So if the polyatomic ion ends in ATE or IDE, okay, most of them begin end with ATE, just a couple begin with IDE. You're going to change that to IC, and then you're going to add the word acid. Now there's also a couple of polyatomic ions that have an ITE ending. If that in the polyatomic ion ends in ITE, you're going to change that ITE to OUS. And then you're going to add the word acid. It's no different. Alright, so let's look at some examples of that. So let's start with this particular acid. Okay, so here's the H that dissolves in water and becomes H+. Here's the rest of the ion, and you should recognize this. If you look at the back of your periodic table, this is the polyatomic ion nitrate. Now, you should note that nitrate on the back of your periodic table has an oxidation number of -1. You notice the hydrogen, remember, ion has an oxidation number of +1, so you have one hydrogen ion and one nitrate ion. That's why this 3, remember, is part of the whole group nitrate. Nitrate is 1 nitrogen and 3 oxygens. Make really sure when you work with the formulas for polyatomic ions that you do not change the numbers as they appear on the back of the table. Okay, however, you're allowed to change the name. So this ATE right here, ATE becomes IC acid. So the nitrate becomes nitric acid. Okay, let's look at another example. Okay, here's the hydrogen. The rest of this right here, that's your polyatomic ions, A1, hydrogen, sulfur, oxygen, 3 elements, polyatomic acid. This, if you look at the back of your periodic table, SO3 is called sulfite. This has a -2 on the back of your periodic table. So when it is combined with hydrogen +1, it takes 2 hydrogen +1s to balance out to 0 the 1 sulfite, -2. So that's why you see H2SO3. Now this one ends in ITE. The ITE ending gets changed to OUS. So this will be called sulfurous acid. Now you may ask, why did I put the back in? Because this is not called sulfurite, it's just called sulfite. It's just one of those odd little quirky things when it comes to the rules for naming. Okay, just for sulfur and phosphorus, we put those back in. If you named this sulfus acid, that's technically not correct. Okay. But if you make a mistake and do that on homework or quiz, as long as you have the OUS ending, it's not going to be a problem. You're not going to lose any points. You just kind of have to get used to it after a while when you see sulfur. Try to remember that sulfur, it's like sulfite or sulfide if it's just S-2. We changed that to sulfurous. It's a little confusing, I know, but you'll get used to it. There's just a couple of them. Alright, let's do a couple more examples. Here's another acid. Now this acid has hydrogen and carbon and oxygen. So you should know now that this whole group must be a polyatomic ion. Now why are there some H's here and H's over here? These hydrogens do not come off of the acid and become H+. Only this one hydrogen here does. It's the way they're bonded together. If you drew out the Lewis dot structure for this, you see these hydrogens are attached to carbons, and this hydrogen is attached to one of the oxygens. So that's what allows it to come off. Okay, the important thing in our lesson today is, well, what's the name of this group? This is called acetate. If you look on the back of your periodic table, this whole thing is called acetate, and it's a -1. So you need 1 hydrogen and 1 acetate ion. Okay, it ends in ATE. So to name this acid, you're going to change the ATE to IC and add acid. So it's going to become acetic acid. Not acetic acid, acetic acid. Okay, one more example. Okay, here is your periodic, back of your periodic table. This polyatomic ion is called cyanide. Okay, this is the IDE ending. IDE is treated the same as ATE. So you would call this cyanic acid. The ones that end in IDE are a little unusual in that when they're in the form of acid, you don't tend to find them. They don't tend to dissolve in the water very well because they like to be gases instead. Okay, so this particular acid, this is what, if you go to the gas chamber, this is what they kill you with. Okay, and in its gas form, it's called hydrogen cyanide. Okay, but you will call it cyanic acid. Alright, let's move on to the second group of acids, the binary acids. Remember that they're called binary, binary meaning two, because they always have two different elements. There's always hydrogen plus just one nonmetal. Now these have something special. They have the prefix hydro that will come at the beginning of the acid. And now you're going to change the end of the nonmetal. These are all ic with the word acid. All of the binary acids will say hydro something ic acid. Okay, let's look at some examples. Okay, you can see right away, just two elements, hydrogen and fluorine. Okay, if you look at fluorine, fluorine is a -1, so you know hydrogen's +1, that's why there's one hydrogen and one fluorine. So how are we going to name this? We're going to start with hydro. All binary acids are going to begin with hydro. Okay, fluorine is going to be called fluoric, and do not ever forget the word acid at the end of the acid. So this is called hydrofluoric acid. Let's look at another example. H3P. You may ask yourself, why does this have 3 H's? If you look at the oxidation number for phosphorus, the ion, it's -3. So it takes 3 hydrogen +1s to cancel out the 1 phosphorus -3. Okay, the way these combine, the ratios in which they combine, is exactly the same as any other ionic compound. You're still going to have to look up oxidation numbers and do the crisscross method or decide if the two ions just simply cancel each other out. Okay, what do you call this one? Well, since it's binary, you're going to begin with hydro again. This is phosphorus. You're going to change that to phosphoric acid. Hydrofluoric acid, HF, hydrophosphoric acid, H3P.